Determining the end behavior of the graph of a polynomial function. Remember the definition of a polynomial. It's actually p of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1. And you keep counting like this until you get to a constant. So we can call that constant a naught. Where the degree of the polynomial is what? Where the degree of p is in fact equal to n, where n is a positive integer. Okay, so remember that a polynomial function doesn't have any square root symbols in it. It doesn't have any cube roots and so on and so forth. N has to be a positive integer. Let's look at part A. F of x is given to be negative x cubed. You just have to make sure the polynomial is in descending order. So we're looking for the highest degree here, and we're going to make note of that. The highest degree here is this term right there, and that's really key. So for part A, B, and C, we're just looking for the term with the highest power, and that's that one. And we do need the coefficient as well. For part C, it's a little bit tricky, but you could see that f of x is going to be similar to something. And what is f of x going to be similar to? F of x is going to be similar, that's the similar symbol, of 4 times x to the 4th power. Now I don't need to expand the entire thing to see that. You can see from the two factors and the two multiplicities, this is going to have an x squared, and this is going to have an x squared. So when I multiply the x squared and x squared, we get x to the 4th. I do need the coefficient of 4 though, because I need to know if this is positive or negative. Once you have that, I can also circle the first term here. That is in fact going to be the first term, or the term with the highest power or highest exponent. Once I have that, I could actually draw the behavior of this. We're going to say that here, why don't we say it this way? F of x is similar to opposite of 3 times x cubed. And what is the end behavior for that? It goes something like this, right? I'm just going to draw the ends. And part B, f of x equals negative 6 times x to the 6. What does that look like? That looks like negative x to the 4th. Once again, I'm just going to draw the ends. And because 6 is even, it looks like x to the 4th. Drawing just the ends here, the ends are going to go down on both sides. Who knows what happens in the middle? I don't know. It could do some stuff. But the ends are what you're focusing on. You're just focusing on the end behavior. And the last one here, if I just draw the ends, both of them are going up. Because you should know how to graph f of x equals x to the 4th as well, or g of x equals x to the 4th. So really focus on the ends. Let me highlight the ends here. So the end behavior, end behavior, end behavior, end behavior, end behavior, end behavior. Now we just simply match the description that's given. And there you go. We have matched the descriptions that are given. You could read these out loud to make sure. But the key here is actually just draw a quick sketch of the end behavior by noting the degree of the polynomials that were given.